Titanium versus aluminum. How much does the diaphragm material actually influence the frequency response? Can titanium unlock better performance, or do both materials behave more similarly than we think? Let's explore the facts. Hi, and welcome to my channel. Today, in FineCone software, we'll replace an aluminum tweeter diaphragm with a titanium one to see how it affects the response. Before you continue watching, I'd love to hear your thoughts. Your feedback helps us create better videos. Titanium is significantly more expensive than aluminum due to its rarity, complex extraction and manufacturing processes, and higher strength-to-weight ratio. While titanium domes are lightweight, the cost difference in this application isn't as dramatic. Of course, the sound characteristics may differ, but our main goal here is to achieve a flat frequency response. In this software, aluminum has a Young's modulus of 75,000 megapascals, indicating a relatively stiff material. For a 0.05 millimeters thick diaphragm, the mass is about 0.08 grams. The frequency response shows a peak beyond 20 kHz. While this peak is outside our hearing range, it can still have a negative impact on the perceived sound quality. Now, let's switch to titanium. As you can see, it has a higher Young's modulus, making it stiffer. But it also has a higher density, slightly reducing the tweeter's sensitivity. The resulting frequency response curve shows that the difference between aluminum and titanium isn't significant. So in the end, the choice between the two comes down to personal preference rather than measurable performance improvements. The directivity map indicates that the material type does not affect the driver's directional properties, as switching from aluminum to titanium doesn't result in any noticeable change. Here, we'll compare to real drivers, one with a titanium dome and the other with an aluminum dome. As I mentioned, titanium is heavier than aluminum, but the sensitivity of the titanium tweeter is higher than that of the aluminum tweeter. This difference depends on the manufacturer's design choices. For drivers with similar diaphragm thickness and voice coil weight, aluminum generally results in higher sensitivity. The impedance peak of the titanium tweeter occurs at a higher frequency, confirming its lighter moving mass, not a lighter dome. This distinction is important to keep in mind. Now, it's time to compare the frequency response. Both drivers exhibit a flat response, and their off-axis measurements reveal no significant differences in directivity, just as the simulation predicted. Thanks for watching.